So welcome everyone for joining this session. My name is Nick Vermundi. I'm a technical marketing engineer with Cisco, especially focusing on everything around open source, container, and programmability in general. So in the talk for today, we're going to be taking a look at the brand new program, which is called consul-terraform-sync, and what we have built so far for our Cisco ACI fabric. So I'm going to really focus on the demo really, because we only have 15 minutes. So I want to show you what we have built and what's the use case. But first, a quick overview about NIA maybe. So NIA, which is Network Infrastructure Automation, is a program that has been launched by HashiCorp to give users the opportunity to leverage infrastructure as code paradigms for data operations in regards to networking and security in particular. So if you think about it, day one or day zero, if a developer needs to deploy his application on the network in his environment, he can leverage already Terraform to programmatically manage and deploy infrastructure artifacts such as networking components, also more like application level components. But what happens day two, right? So let's say if you are a developer who wants to deploy multiple instances of the same service, so it is expected that the service will grow over time in terms of maybe changes, can be different health check, or also growing the number of instances. So today with Terraform, there is no way to to automatically reconcile the state of the infrastructure with that particular change. And this is where NIA program is very cool and effective, because it's going to be leveraging a new binary, which is called console, or new product, if you like, which is called consul-terraform-sync, that will use console as a source of data to then ingest that source of data into recurring Terraform plans. So as soon as there is a modification on the service side in console, then consul-terraform-sync will detect that, take all the required inputs from console, and then feed that into Terraform, a Terraform plan, and the plan will be triggered. Whether that to do Terraform, just a Terraform apply, or Terraform destroy as well when there is no need for a policy in the infrastructure anymore. And obviously there are a couple of direct benefits of that. So first is reduce time to deployment, because even if you have, let's say, an SDN solution, there is still a gap at the moment where the user or the developer needs to deploy his application. He may have the network component in place, but there is a gap between the application requirement and the network requirement over time, right? So even if you have SDN solution and Terraform, it's not enough to have this day to operation automation. The second benefit is really you reduce the risk, because now as it's infrastructure as code, all the configuration of whether it's the consul-terraform-sync itself or the configuration of the Terraform plan, all the logic is basically handled in a single source of truth, which is your version control system, right? So it's easier to detect any lack of compliance, or if you lack things like best practices. So it's better to be able to check your code on a daily basis and make it evolve in the right direction as a team, right? So and of course the third benefit is that your infrastructure is always up to date with the above layers. So essentially we are making the application layer and the network/security layer best friends again, right? They are always aligned together. And so let's take a look into our use case with ACI and NIA and consul-terraform-sync. So the overall idea of our first use case, because the launch was literally yesterday, so we have our first use case, which is essentially using ACI PBR policy to scale the number of backend server instances when you have a load balancing service that is handled by the fabric. So if you don't have, let's say, ACI PBR, usually what happens, you deploy a VM, and then from that VM, let's say in the case here, you're the user here on the left, you want to reach that VM, then traffic just gets routed to the fabric, and the fabric forward the traffic to that VM. So now let's say you want to define 3 services, right? So actually 3 instances of the same, let's say, services. So you don't have any load balancer. So you're still using different IP addresses to reach those VMs or those backend services. And then again, the fabric just forward the traffic. But now the PBR function of ACI allows you essentially to put a VIP on top of any sort of arbitrary service. So how it happens is that you create a rule, for example, here, that will match source and destination, right? So source may be anything like the wildcard 0000/0. So basically any traffic that's reached the fabric then will be matched into a specific rule. So the rule here will say, for example, if you're coming from user 1, you get classified into this wildcard. And if the destination is my VIP address, then automatically ACI can redirect the traffic to one of the service instance that are sitting behind this VIP. And it's done entirely in hardware. So it's really like in hardware load balancing, completely stateless. And as a result, it's just the destination becomes a simple hash, right? There's no like sticky session or things like that. It's a stateless load balancer, but very scalable and very fast. So in our case, to be able to interact with ACI, we need to influence 2 policies in ACI, which is the redirection policy and the destination policy. The redirection policy is essentially a policy that tells, okay, I'm going to create a service, let's say a VIP, if you like. I'm going to instantiate a PBR policy that will have a name and that will contain multiple destination policies. So in our case, the redirection policy can be associated to the VIP itself, and the destination policy is the policy responsible for saying, look, okay, I want 1 VM, 2 VM, 3 VM. I mean, it can be bare metal server. Actually, it's just IP/MAC address pair. So you're defining this. And as a result, what you can also do is you can scale in and scale out over time. You can say, okay, I need maybe 2 endpoints, I need 3, I need 1, or I don't need my policy anymore. And you can do that in ACI by programming the fabric using its API. And in our case with NIA, you can do that by essentially looking at the console payload, and depending on what the payload is, create the corresponding policies, right? So let's take a look at this in reality. Oh yeah, what I wanted to also mention is that it can be from an external user, but it can also be if you have another tier that wants to access your VIP. So effectively here on the right, the server will also access the VIP, and the traffic will be redirected to one of the service instance. It can also be in the same subnets, because in ACI, we don't really care about IP and bridge, and forwarding. ACI, regardless of that, will make sure the packet arrives at destination, depending on the policy you have created. So it really doesn't matter if it's in the same subnet or not, if it's bare metal or virtual. So let's take a look at the demo there. I'm going to switch to my session here. I'm just going to check a look on time, how we're doing. Okay, that's good. Okay, so now I've got 3 services here. And they are all configured like that. So I've got just the name of my service, the instance, and then the MAC address of that instance and the check. So I've got essentially Nginx running on port 80. and I'm just checking that the service is running by having curl, right? So I'm just checking with curl. So if I look into, so at the moment the service is down, and I'm just taking a look here, you can see on the console nodes that the service is not there. And in ACI, this is the list of the policy-based redirection. I've got existing policy here, but they are unrelated to our demo. So basically we have an empty situation. It's day 0. So what I want to do now, I'm expecting the developer to start the Nginx service, right? So I'm going to start it, right? So I should see that in console, yeah, now it's already up, and I should see a Terraform plan that is running. So here you can see I've got my Terraform plan that has been triggered. And I want to check that now in ACI, I should see a new, yeah, I see a new policy-based redirect that has been created. And I can see now that a backend server has been added to it. Now, what I'm gonna do is also add a second one. Let's connect to that one. And a third one. So I should see now in console, I've got my 3 service running. I can see the check. I can see the curl is responding positively. And in ACI now, it's there, right? Oops, sorry. I can see that now I've got 3 server instances, all with a name that is provided by console payload into Terraform-sync. And basically now I can start using the VIP to start reaching my server, right? Let's see now if what happens if, for example, the service check is failing, right? So now I'm going to simulate this by stopping Nginx. So the infrastructure should react dynamically, right? Oh, you can see here, Terraform plan is launched. And if I go back to my ACI environment, I can see that my service has been updated. And now if I was to just remove all the service, right? So basically stopping the 2 other one, or removing the application is more equivalent. I should see here, if everything goes well as expected, this last service should disappear and the policy is updated to, which is back to our first stage, which is no policy at all. Right. Okay, so that was it for the demo. So just go back to the slide. So just to conclude here, so hopefully this gives you a nice quick peek into what we have built with ACI. So this is our first module. We believe that it's already quite useful, and we're going to continue our effort to provide more modules over time and to basically meet our customer use cases. If you have any intent to maybe test it, here is the link to the Terraform registry. It's basically behind NIA, there is modules. So all the modules are available on Terraform registry. So you have the name of the module, which is auto-scaling. And also please take a look at the NIA program documentation if you want to know more about this integration. And thank you for joining this session again. Enjoy the rest of your day.